All right, so last time, right, we talked about the very basic measures of, central tendency and spread. So we talked about basically mean, median, mode, range, and standard deviation. Okay? Now, we're going to use what we learned last time to compare data sets, right? So if you remember on that last, on the handout that you had to do for today, and one of the questions was comparing like a wall AC unit to a central AC unit, and basically you had, basically you had like the prices, right, or the cost, monthly cost for the central and the wind. Okay, so now you have that information. Fine. You have how much it costs every month if you have central AC, and then you have how much it costs every month if you have the window unit. Fine. How do you now use that information to determine which of the two you should go with? Well, here it is. So one thing is we can use measures of spread like range and standard deviation to compare sets of data. All right, so what we're going to do is we're going to use our graphing calculators to find central tendency and measures of spread, right? So let's take out our calculators. And you know what? I'm going to go quickly to example 7 here. Example 7 is talking about metabolic rate. And this is the rate at which your body consumes energy. So we talk about, I have a very high metabolism, I have a very low metabolism, and I can't lose weight. Whatever, right? So it's the rate at which your body consumes energy, and it's in terms of how many calories does your body consume or get rid of within a 24-hour period. So here we have group 1. So this is important. You'll get more into this when you're taking an official stats class. Is you have the metabolic rates for 2 different groups of men, right? When most of the time when you compare things, you can't be comparing apples and oranges. So you can't compare, a group of 30-year-old men to a group of 7-year-old women. You know what I mean? Like they have to be comparable. So here we go. Here are 2 different groups of men. Which group, it says, has a greater variation in metabolic rate? Okay, so we're looking for variation. All right, we're going to use our calculators for this. So we have group 1 and group 2. So what I want you guys to do is take out your calculators, and what we're going to do is we're basically going to put in those 2 groups in list 1 and list 2, just like we were doing before. So we're going to click Stat, Edit, right, Enter. And what you want to do is you want to type in the numbers in group 1 into L1, right? So 1507, 1619. And then the numbers in group 2 into L2. So one thing, I've already done this, but what I want to show you is at the very bottom, like you see how like it keeps a counter? So this is L1, 13, 14, 15. Just make sure that you do have like 20 terms. So I'm going to give you a minute or so. Huh?
Like everyone on the chart?
Yes, everyone in the chart. So in list 1, in group 1, there are 20 numbers, right? From the 1507 to the 1656. Please go ahead and enter those into L1, and then click the right arrow button and enter the ones from L2.
So before you turn it?
Right. So 20 in one, 20 in another. I've already done it. I'm going to stop this recording. I'm going to give you guys about like a minute to do it, okay? Okay, so now we've entered our numbers into list 1 and list 2. What we're going to do is we're going to quit. So second quit, go back to the home screen. Okay? Now, we're on this step. Okay, so we're going to click Stat again, same button. Right arrow to go into the Calc tab. And what I want is one variable statistics. Okay, here, make sure that first one where it says list, it's L1. Okay, If it's not L1, here's how you're going to make it L1. Second stat, and we're going to hit L1. All right, this is what it should look like. Max, okay, if you have the TI-83, I'll tell you, this is good. Parentheses, second stat, L1. Okay, now we hit enter, okay? On calculate, hit enter. Go on calculate and hit enter. And this is what you should get. This is everything. You have X bar, you have sigma, you have everything, right? So here's what we're going to do. We're going to write down the mean. X bar, 1603.9. Now, I want the median. You see how there's that arrow on the bottom left, right? That means there is more stuff underneath. So if you press the right arrow button, the down arrow button, look, you've got a median over there.
Oh, man.
Right? Median, that's X tilde, 1691.5. Oh, sorry, it's 1591. Shh. 1591. Okay, the range, right? The range is max minus min, remember? So, guys, the minimum is 1429, and if you keep going down, the maximum is 1764. So 1764 minus 1429, so the range is 335. What we also want is standard deviation. Now, standard deviation was way up here, okay? Okay, so we have capital SX and we have sigma. Okay, we're gonna do the capital S only because this is of the entire population. Sigma is not of all of them. We'll talk about that later. But standard deviation, so we're gonna do SX 100.2. Okay, perfect. All this for list one. We're ready to move on? Clear this. Let's do the same thing. So here we're going to start with step 5 again. Okay? Click Stat. Right tab for Calc. One variable statistics. Now I want list 2. So to change that, second stat, list 2, go on to calculate, enter. Okay? Yeah, you just press enter, Max. So, again, mean X bar is 1,604. Median X tilde is, if you go down here, 1605. The range is going to be 1723 minus 1476, 247. And the standard deviation for this is 54.6. Okay, perfect.
I have a question.
Yes. All right, so the question was, which group has a greater variation in metabolic rate? Okay. So let's take a look at this. Look at, in list 2, look at the mean and the median. Do you see how close they are? Okay. And as opposed to list 1, look how the mean and the median vary from one another, right? So that's one thing. That means there is greater variation. Also, look at the range in list 1 is 335, whereas the range in list 2 is 247. That means in list 1 there is a greater spread. So in list 1, mean and median are far away, range is greater, and look at the standard deviation. Higher standard deviation, okay? That means list 1 is has the greater variation. Okay? Yes? So it's always more desirable. Like for example, when I grade a class's tests, right? And I find the mean and I find the median, it's always most desirable when the mean and the median are super close to each other. Okay? All right, are we okay with this?
Yeah.
Okay. Now, let's talk about a frequency distribution. All right, so this number, we're going to change to 34, typo, okay? All right, so let's move on then. This, right now we're going to talk about a frequency distribution or a frequency table. Those words are interchangeable. This shows how a data set is partitioned into several categories, right? So it lists all of the categories and the number of data values in each. Okay, so take a look at this example. These are the winning scores for the first 42 Super Bowls. So the very first Super Bowl, the winning team scored 35 points. And the 42nd Super Bowl, the winning team scored 17 points. Okay? So what we're going to do is we're going to make a distribution table. Okay? To do this, first we need the range of the data. So we look at the minimum here is 14 and the maximum is this one. Right? So the range goes from 14 to 55. Okay? That's important because when we make our table, all right, we know to go, let's say, from 10 to 60, right? And we're not going from like 0 to 200 and wasting space. Okay? Now what we need to do is we need to determine the classes or the categories of equal length. So for data like this that goes from, 14 to 55, again, there is no like set rule for this. You just have to go like what's most efficient. It's a good idea to split it up into categories such that, they go from like 10 to 19, 20 to 29, 30 to 39. You sum them like you lump them like that, okay? So this is a reasonable set of categories. So you determine the classes and then you need to tally the data, okay? So what you do is, okay, for winning score of 10 to 19, right? How many are there? And you go down the list, right? How many are between 10 and 19? Well, you've got this one, this one, this one, this one, and then one more somewhere. Where's that next one? 1, 2, 3, 4. There is a 16 right here. Okay? So there are 5 values from 10 to 19. And then similarly, 20 to 29, there are 16. 30 to 39, there are 15. So we're just counting, okay? And so on and so forth. Now, just make sure at the end of the day that all these add up to 42, right? That is to make sure that you've accounted for all of them. Okay, next one. Next, we need to calculate the relative frequency. And this is basically, okay, so there were 5 from 10 to 19. So out of the total 42, like how much of the total is that? Well, 5 out of 42, it's 0.12, right? And 16 out of 42, and so on and so forth. Now, what should these values add up to? 100 or? So 0.12 and 0.38 and 0.36 and 0.10 and 0.05 should add up to 1, right? If you convert them into percentages, yes, then they will add up to 100%. But those should add up to 1. So these are ways that you can check your work. Okay? All right. Class boundaries are the numbers used to separate the classes, but without the gaps created by class limits. Class midpoints is exactly that. It's like the middle of each midpoint, right? I mean, it's the middle of each class. So here, let's do this for this table. Class width, right? Each one of them goes from 10 to 19. So how many numbers in each class? From 10 to 19?
9.
One more. 10. All right. Okay, the lower class, these are the lower numbers of each boundaries, of each category. So 10, 20, 30, 40, 50, and then the upper is 19, 29, 39, 49, 59. Okay. Class boundaries, these are like the numbers in between one class and the other. So one ends at 19, the other starts at 20. So the boundary is 19.5. Like one ends at 19, one starts at 20, right? Here?
Oh,
It's in between. So actually, so we go from the very beginning. So 9.5, 19.5, 29.5, 39.5, 49.5, and 59.5. Huh? Huh? Oh, class boundaries, those are the numbers. Okay, so look. This is from 10 to 19. This is 10 to 19. And then 20 to 29. So 10 to 19. And then 20 to 29, right? So the boundary is, what's the number in the middle? Okay? So that's what separates one from the other. And then class midpoints, the way you find the midpoint is upper class limit, lower class limit, plus upper class limit, and divide by 2. Right? So in the first case, if it goes from... So look, if it's 10 to 19, the midpoint will be 10 plus 19 over 2. You see what I mean? So that would be 14.5. And 24.5.
and 26.
34.5. 44.5.
54.5.
Right. Okay? All right. Now, this is fine, but what if you're like the graph type of person, right? What if you want to publish this for the average person and you want to make it very easily recognizable? Well, then you make a graph out of it. The graph version of this exact same information is a histogram, right? So that's a graph consisting of bars of equal width drawn adjacent to each other. So they're stuck to each other. There are no gaps. The horizontal scale represents the classes. The heights are the frequency values. So you see the table here? These would be the horizontal axis, and these would be the vertical. Oh, sorry, not those. These would be the vertical. Either of these. All right? So, in this histogram, for example, look, it's the same exact thing. It's the same exact information as that table. Look at this is still the winning scores of the Super Bowl. These are the categories, right? And in our table, what did we say? How many was in the 10 to 19? 5, right? 20 to 29, 16. 30 to 39, 14, and so on and so forth. Okay? So same situation. Okay, before I take your question, and these are the relative frequencies. All right, quartiles. This you see a lot when it comes to like your SAT and PSAT scores, right? Quartiles and percentiles. Quartiles are the values that divide your data into 4 equal parts. Okay? So you have the 42 points, right? Split it down the middle, and that's how we get the median. Remember, that number in the middle is the median? Okay, if you split it down the middle again, that value, so like the median of the lower half, we call that Q1. The median of the upper half, I call Q3, right? So what happens is Q1, Q2, Q3, okay? So take a look at Q1. Here, this is Q1. It's 29, right? What is that? Okay, so basically, look, we've now separated this into 4 parts, okay? This is the bottom 25%. This is the upper 75%. So Q1 separates the 25% from the 75%. The median separates the bottom 50% from the top 50%. And what does Q3 separate? The bottom what from the what? The bottom 75. Right, from the top 25. Okay, so we're gonna do that for this now. For the Super Bowl scores. Okay? Yeah.
What are the stats in like the Trig class?
So what we're going to do next is we're going to use the data set for the Super Bowl, and we're going to determine Q1, Q2, Q3. So the first thing you have to do is sort data in increasing order. Okay? So that's what we're going to do now. You see this list here? We're going to sort them from smallest to biggest. Okay? And you have to do that, you just have to be super careful while you do that. All right, so let's do it. Let me stop this for a second. All right, so here's the list finally in all its glory from smallest to biggest in increasing order. All right, so we need to find Q1, Q2, Q3. That means first you have to split it down the middle. There are 42 of these, so if you split it down the middle, you get 21 and 21. So let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So after that 29, right, that's the median, which is also Q2, right? But what would that number be? 29.5.
What number do we add? Do we need to know that?
Yeah, because it's the median, right?
What number do we add?
Huh?
We added a number. Add 29.
Oh, well, here. So it's supposed to be after 23, 3 24s, and then a 26. Okay. So we'll find it. But okay, so now the first half, let's split down that in the middle. So if we have 21, there's going to be 10 and 10 and 1 in the middle, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is Q1. And then same thing here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is Q3.
Oh, so 29.5 is Q2.
Correct. So Q1 is 23. Q2 is 29 plus 30 divided by 2, which is 29.5. And Q3 is 35. Okay? One interesting thing that we always do when we're analyzing this stuff is we do a 5-number summary, okay? It's like, okay, give me the stats on this person, right? Or like, give me the, like, when you go to the hospital and like they admit you to the hospital, what do? They do like your, right. Oh my gosh, what do they call that? Anyways, so this is like the same thing, right? It's like, okay, like what's the 5-number summary on the list? So basically 5-number summary, like on the test or quiz, I'll just say, give the 5-number summary. And you have to know that the 5 numbers are minimum value, Q1, Q2, Q3, maximum value. Okay? So here, the 5-number summary is minimum 14, Q1, 23, Q2, 29.5. Oh, vitals, that's what it is. They take your vitals. All right, hang on. So Q3 is 35, and max is 55. Okay? So that's the 5-number summary. All right. So let's pause here for briefly, and let's do this handout.